All right, guys. This is going to go on the next page of your notebooks. This is going to be 13.2 continued. You don't need questions and reflections no more. The last notebook check is probably going to be the last notebook check that we do. Yeah, it's probably going to be the last one that we do. So, yeah, you guys don't need questions and reflections. I do want you guys to still keep on taking notes just because a lot of you guys are going to trig stats or pre-cal next year and you're going to do the same thing. All right, for this, I'm just going to go through some work, just work things out. Sine x plus cosine x, because it's squared, we want to square it. Oh yeah, I forgot to mention that you guys were probably going to have a quiz on chapter 13 next week. Probably, I want to say Tuesday of next week. Yeah, probably Tuesday of next week. I'm going to give you guys a quiz on chapter 13. Okay. Okay. So here we're just going to FOIL. So we have sine times sine. That's sine squared, right? That's just like sine squared x. Sine times that is plus sine x cosine x. So here I'm just foiling plus cosine times sine. I'm going to write it as sine x cosine x. It doesn't really matter the order that you write it. I'm just writing like that so it matches. Cosine times cosine is cosine squared. So I'm just going to simplify. I have sine squared x plus 2 sine x cosine x plus cosine squared x. I have cosine squared, and sine squared. Okay, remember, and there's a plus, right? Remember, sine squared plus cosine squared is 1. So my answer is 1 plus 2 sine x cosine x. That's my final answer there. Here I want to verify. So remember, I want to pick a side, right? To me, I think the right side looks a lot harder. So I'm going to work on the right side. So I'm just going to FOIL 1 times 1 is 1 minus sine theta plus sine theta minus sine squared theta. Now, if we notice the middle, negative 1 sine theta, negative sine theta plus sine theta, that kind of cancels out. So we just have 1 minus sine squared theta. And then this is a Pythagorean identity, right? If you guys remember correctly, we have sine squared plus cosine squared is equal to 1. That means cosine squared is equal to 1 minus sine squared if we subtract. So that's kind of what I'm doing. This is just cosine squared, which is exactly what the other side is. And that kind of checks out. So I'm done with that. Okay, this problem's a little tougher. I want to pick a side. I'm going to probably pick the right side. And what I'm going to do with the right side is I'm going to convert everything to sine cosine. So secant is 1 over cosine. Tangent is sine over cosine. Plus cotangent is cosine over sine. Like that. And if you notice, the bottoms have fractions, right? Like the bottom have fractions, sine over cosine, cosine over sine. Like it's a fraction. So the trick here is I'm going to multiply the LCD, which is sine theta, cosine theta, top and bottom. That's the trick there. Whatever the bottoms is, I see a bottom that has a sine, I see a bottom that has a cosine. I'm just going to multiply that top and bottom. And what happens, if you multiply the top, you have a cosine on the bottom and a cosine here, so that cancels out. That just becomes sine over. Now the bottom, the first term here has a cosine on the bottom. So the cosine here and the cosine here cancels out. So you have sine times sine, which is sine squared. Under that same logic, sine and sine cancels out, right? Like this sine and this sine cancels out. So you have cosine times cosine, which is cosine squared. We should know what sine squared plus cosine squared is. It's actually 1, and we get sine theta, which is exactly what the other side is. Okay, next slide. I want to pick a slide to work on. It doesn't really matter. I'm just going to work on the... I don't know. I'm going to work on the left side just because I see more stuff. Like, it shouldn't matter. Like, it doesn't matter which side. As long as you pick on the harder side. That's kind of the trick. Here I have... I want to convert everything So I get tangent. So tangent squared over cosecant squared. I don't know. So tangent squared is sine squared over cosine squared times 1 over sine squared. If I notice what happens here, these two things cancel out. So I get 1 over cosine squared. 1 over cosine squared is secant squared, and this is a Pythagorean identity. So that's 1 plus tangent squared. So that's a Pythag. Right? Like, I just know my Pythags. So that's why I can make that jump. Check. All right, last problem for the day. I want to pick a side. Obviously, I want to pick on the left side because it looks a lot more difficult. Yeah, let's do it, the left side. So problems like this is really hard because it's like in my head, I'm like, where do I really start, right? I have a 1 plus tan over sine plus cosine, right? So what I'm going to probably do, I don't even know if this is going to work. I have no idea if this is going to work. Huh. Okay, I'm just gonna try a couple things just to see if they play out. And who knows, maybe they will. I really don't know. Okay. I'm gonna change everything to sine and cosine. Yeah, sorry. So 1 becomes plus sine over cosine like that. So far, so good. What I want to do now is 1 is super duper dope. 1, I'm going to convert to cosine over cosine. Okay, and the reason why I can do that is 1 can be anything you want over on top of each other, right? The reason why I specifically chose cosine over cosine is because I notice that this term had a cosine on the bottom. So, you know, by doing that, what that allows me to do is that allows me to kind of combine the top. Like so. So from here, what I can do is, this is technically under 1, right? Remember, we're dividing fractions. When we're dividing fractions, the idea is that we're multiplying by the reciprocal. So that's what I'm going to do. So I get cosine theta plus sine theta over cosine theta times the reciprocal of the bottom is 1 over sine theta plus cosine theta. So what happens here, these two terms will actually cancel out because they're exactly the same. So I get 1 over cosine theta, which in reality is really secant theta, which is exactly what I want from the left side, right side, right? That's pretty much all I have for today. Like I said, you don't need questions, reflections. It'd be nice to keep your notebook in like the same order just because it just makes sense, but we're not going to really do another notebook check for this whole semester. Like, that was the one. Okay, so hopefully you turn that in, or else you pretty much got a 0 on that. All right, guys. This is due on Thursday, so let's get that done. And yeah, have a safe chunk of the week. Or actually, sorry, this is due on Friday. See you guys.